It's been really exciting because we can extend the presentations to a much wider audience, I suppose, than if we had done it face to face. But like I said, this isn't about, us talking. This is about our two great speakers tonight. And first up, we have Benzies talking about OSINT, or open source intelligence. And he'll be talking a little bit about how to scale that and how to use that for what he does. Benzies has a great bio that I'll sort of paraphrase really sort of terribly. He's been in IT since he was 17 and really is a veteran of IT now and works in IT security, a long varied career from a variety of things to where he is now. And so let's all welcome Benzies to the stage. Ben Menzies, and thank you very much. Over to you.
Hey, thanks very much, guys. All right, let me share my screen first. All right, here we go. How are we going? Can we all see that?
Looks great.
Perfect. Okay, cool. So yeah, thanks for having me, first of all, here at Seasides. It's a great opportunity to talk about the things I do outside of work, which very much relate to what I do at work as well. It feels good. Even in this virtual audience as well. So, it's really good to be able to do this sort of stuff outside of work in a virtual environment and present, like you just said, to a much wider audience of people. So today we want to talk about OSINT and how we do this at a much larger scale. So first of all, an introduction. Thank you, Silvio, for the introduction. I am Ben, but a lot of people refer to me as Benzies. And I also have my username mostly reserved online. So you can see there I have my Twitter account, my Twitch streaming, my LinkedIn, and my GitHub, mostly reserved for Benzies. I am a husband, I'm a father, I'm a mountain biker, and I also stream those mountain biking events live as well. So outside of this, you're very much welcome to join me on my mountain biking adventures. To start you with, I have a little quote here, which I decided to coin myself, and that is the famous word, which is a picture is worth 1,000 words, but I think that the data is worth a lot more. So today's purpose of this talk is to go through at least 3 key points here. And we'll be looking at capturing user-generated data related to coronavirus or COVID-19. We want to baseline that data and find out the limitations around it. And then what do we do once we've got it as well? And one of my friends sort of said to me, why do you want to do this? And a lot of the time it is a good question. Why do I do this? And I'm interested in finding out what we can get online and what is available to capture. But mostly, what are people saying about coronavirus at the moment? And who are these people? And are there any trends around this sort of data as well? So to start with, we want to start looking at capturing the data. And I look at this as sort of a 3-stage approach to getting this data. So the very first point here and focus is to ask some questions about what we want to do. Instead of the who, what, when, where, and why, I want to focus on the what, where, why, who, and when. And so to go into a bit more detail, we look at those and we're saying, what are we searching for as a really good starting point? Where is it coming from? Why do we know it's right instead of why are we doing this? Who shared it? And when was this information shared? The second stage we'll focus on is some of the tools that we want to use. And the most common sort of tool that a lot of OSINT people use is a web browser because the tools that are provided for OSINTing are provided through a web browser. So simple things like Google searching or Twitter or Yandex. We can look briefly at using APIs, but we won't look into that too deeply because this is OSINT. We want to focus on freely available data. And then we're going to be looking at batches of capture. So scripts and apps will help us along this journey. The last part is, I'll just minimize that one. The last part is automating these as well. So once we know what we're looking for and once we know how to get it, how do we automate that so that we can have a continuous feed of data into an application of our choice. And we can focus on cron jobs or any sort of data streaming application. So the first stage we'll focus on is asking the questions for the data to capture. So of course, the what, where, why, who, and when. So to make it obvious, what we are looking for is coronavirus. And we've got a few keywords here to begin with, which is corona, space virus, coronavirus, COVID-19, COVID-19, and COVID-19. And those are sort of some keywords that people will use on social media to track coronavirus. The where is always good, mostly social media at this point, because we are looking for trends in people. And we've got at least 6 options here. There are obviously more, but 6 here would be Twitter, LinkedIn, Reddit, Facebook, Instagram, and TikTok for anyone who still has TikTok installed. But today's focus is mostly on Twitter. As ambitious as I wanted to be, I realized the enormity of my work if I started focusing on different social media. So why do we know it's right? Well, we can go to any of these social media applications and type in the keywords specifically to search for, and we can see there where I've highlighted the search field and sorted by latest, and we can see the keywords highlighted in those few tweets that I have there. And we can also see this in the LinkedIn data as well. If we do the same search terms, we can sort by latest, and we can see the keywords pop up in there as well. So who is it coming from? This is probably more of an obvious answer, that we see that the usernames highlighted in these events. And then the when as well is also quite obvious, is that we get these events within a short window of time, typically within a few minutes, even a few seconds. So we know this is actually quite active in this. So the next part is thinking about the tools that we want to use. So web browser is your most obvious tool to use. And specifically, Firefox is my preferred web browser for these types of things, because we can separate these tabs into containers. And the containers are separations of cookies and sharing of information between them. So in this example, I've created many different containers, and specifically to separate Facebook and LinkedIn from each other so that the targeted advertising is less. But we can also do the same for if we're looking for using different accounts in Twitter or Facebook and whatnot. But the other benefit to using more advanced web browsers like this is that we can access the console to look at the data generated. The next one is APIs. So Twitter has great API features. It provides a lot of data when you search for it. There are some limitations to that, and that is that you will need to pay beyond a point. But for free use, it's quite good, though it steps it a little bit outside the OSINT boundaries that you need to actually register an account and capture that data through the account. But luckily, it's not too bad. And with this tool, Insomnia, which is the tool, we can actually easily generate these queries and then create a script just here, all generated through the application itself to easily create new jobs. The next part is to look at what scripts and apps are already available, to leave the hard work out of it. And specifically today, like I previously mentioned, we'll be focusing on Twitter data only. The Twint application is the preferred application in this circumstance. So the automation, or getting the data and streamlining this a little bit more. Two really easy ways to approach this is through cron jobs. Cron jobs can be timed and batched on Linux systems mostly, or to use a data streaming application. Now, the thing with cron is it's pretty straightforward, pretty simple. You just need a script and you need to time it. You can make a lot of scripts as well, and you can run them in parallel. And here specifically, I have highlighted Parallels as a Linux application to run multiple applications at the same time in parallel and capture data quickly. But as I found out later on, there's some limitations to Twint and running in parallel. So I had a little quote there after I figured that out. That's mostly for people who like to live, laugh, and love. The next thing to streamline all of this is to use a data streaming application. And so in this example, we have two applications we can use, which is Elk and Splunk. So now that we've figured out a few things on what we want to get, how we're going to get it, we can look at starting to get that data. And as I mentioned before, we have the application called Twint. And it is fantastic. It's a pretty amazing tool, actually. And it's very, very easy to use as well. Sorry, that opened up a new window for me. It explains on the GitHub profile there how to install it, and you can install it through various methods, and the most easiest being pip as well. So you can just literally type in pip install Twint, and you can get going. Of course, right down into capturing the source and installing it via source. On the GitHub page, they provide some examples on how to capture that data. So in this example, we have here, we're looking for the keyword COVID-19, but we can also specify that these can be usernames that we also specify instead of just keywords. In these examples, we also have an option to capture tweets from a certain period of time, to export them as CSV or JSON files, and to even export these into an Elasticsearch engine as well. Once we have figured out the data and how we want to capture it, we can automate that into cron jobs again, and output those files quite easily into JSON files. But it even has an option to export this directly into Elasticsearch. And easily enough, you can run a container that starts up Elasticsearch. And once you've started directing all that data into Elasticsearch, you should have a data feed. But I decided that was too easy. So I wanted to set a little bit of a challenge for myself and put this into Splunk. And I guess the question is why did I want to do this? And well, the first point is that it is a challenge for me. I preferred using Splunk. It's my tool of choice for data streaming. I thought it looked pretty easy. And again, I like Splunk. It's very easy to use. But I want to make a point here about when I started going through this journey is that it looked easy. You're probably thinking at this point, I could have done a manual search and imported what I needed into Splunk, or created the cron job and automatically ingested it through Splunk through their inputs. But again, I thought I could make this a little bit better and generate an app for Splunk because I thought it looked easy. So building a compatible app, Splunk has a few options to make this this journey a bit easier. There is the Splunk add-on builder. You can do Python scripts, batch scripts, and I think there's another input type there. I just can't remember off the top of my head. But they automatically generate code for you and various variables for you to create as well, so that the code's quite easy to work with. And Twint also has some modules which give examples on how to code your own custom inputs for all this sort of stuff too. And in this example, they're looking for Donald Trump's tweets and to look at a period of time as well and to export as JSON. And this is all Python code as well. But as I found out, as I started coding all of this in Twint's module examples, I started running into a bit of a dependency hell. And as the comic explains here from XKCD, this is exactly what this felt like as I started to generate this code. But pip makes this life a little bit easier because you can specify all the dependency requirements for Twint into a specific directory instead of into the Python directory. But even then, there was still some trouble behind all of that. And the real reason that there was trouble is because Splunk has its own Python SDK that's separate to the operating system. And the biggest reason behind that is so that you can run this on any operating system. So after a little bit of struggling with generating code for Splunk myself, I decided to see if I could put this into a container. And luckily enough, I have a bit of experience with Docker containers, and they are absolutely fantastic to work with a lot of the time because they are super easy to build. All of the dependencies are met within the container. They run separately to Splunk input processes. So that's a real big advantage there, as well as that I can restart Splunk at any point and the ingestion or the data capture still continues to run in the background. And the other advantage here is that I can actually export those events from the container itself and put them directly onto the host volume storage. So without saving you the time of all the problems I went with in generating this code as well, I mostly highlight the important bits of this all working together. And it's fantastic. Python is fantastic. It makes it so easy that I can just import the Docker module and import the Twint module to help me out here. Actually, I don't even think I need the import the Twint module in this example. I think I just left that in there by accident. But anyway, I specify a few variables here, which is the keyword for Splunk. There's another option in there to translate the tweets as they come in. And all of that there is sent to the Docker module to run on the Docker daemon on the host. And then, of course, once it's finished running, it actually removes itself, which cleans up the directory and the processes really nicely as well. And this is just to visualize how this code works. So we can see if we start on the left here, we specify the Splunk input, which calls this Splunk Python SDK to execute the Python script and start a volume for the container. The Docker container then starts up the Twint application, which pushes off the tweets into the Google Translate API, which feeds it back down into the storage where Splunk will read that JSON file and then ingest that into the indexes. Once the full process is completed, it will remove the Docker container. I think it's pretty cool. And I've been wanting to work on a project like this for a while. So this has been a pretty good excuse to work on. So what does this look like from Splunk's point of view? Well, it's actually quite nice. Once you get all this sort of stuff working, you can avoid the CLI and just use the GUI from Splunk instead. And it's pretty straightforward at this point. Once you've done all the hard yards, you can specify a name for this type of input. The keyword is really important again. This is a little feature of mine that I made, which is the since option, and that's how many minutes previous to the current time do you want to search for. And in this example, I use 60 minutes. The option to translate the tweet or not is really important too, because there are limitations to running this. And then the interval in which this runs at, which is also really important. We'll get to that soon. The rest of that actually doesn't matter. So where we specify source type and index, it doesn't actually matter because I couldn't manage to figure out how to send this directly into Splunk rather than to a file and then Splunk pick up the file. And this is how Splunk picks up the file. So you have to have an inputs monitoring a directory. And in this example, we use the opsplunk output directory. And we're looking for any file name that ends in twint.json. And then the code there, whether you saw it or not, it outputs to, is it date time, the keyword used -twint.json, so that we can easily verify the time that the events were created and what keyword was used. The props conf there is to specify how the data is generated and to enrich it a little bit more, so it's a lot easier to work with in Splunk. So you're probably thinking at this point, it's like a cron job, but with extra steps. You're right, but it works and I'm happy and I can leave it there for now. So now that we have got this all working, how do we baseline this and what can we do with all of this? So we need to capture an event at this point, and we need to go back through our verification of the what, where, why, who, and when. And in this particular event, I've highlighted all of those events. So if we start with the what, we can find the keyword that we use in there, which is coronavirus or COVID. Where it's coming from, at this point, we mentioned Twitter, so we're still focusing on Twitter. Why is it right is we can verify this through the actual tweet itself, that it picks up the keywords in there. Who is it from? We specify that field in here from username. And when. In this particular event, this is formatted to my current time, but the events come in UTC. So it's really nice because it comes in JSON. It's really well formatted. It's very easy to work with. And it's another debate I'll get into another time, but all data should be, in my opinion, JSON or XML formatted. So now that we've figured out what we want to baseline this data, and we want to be able to just sort of focus on one thing at a time. So we set the new inputs to focus on the keyword COVID-19, and I set my time period to this time last year. So any point I run this particular input, it will focus on this point a year ago. And like I said, I'm going wild at this point. I want to get everything related to COVID-19 a year ago. And I want to translate all of those events too, because I noticed that a lot of these events are not English. But I soon learned that there's some limitations around all of this. And we still need to work within the OSINT boundaries. And we needed to find a better way to do this. So now that we're starting to get data, what limitations do we hit? And Google is kind enough to tell me the limitation that I do hit. And at this point, I'm hitting too many requests for this URL. At this point, I'm hammering Twint, I'm hammering Twitter, and I'm hammering the Google API translation. And thankfully, through automation or unthankfully, it keeps trying until it fails entirely, and then it tries again. So here we have a graph that specifies that exactly, and we can see a fairly inconsistent data capture where we have the peaks and troughs of data capture. So I needed to find a way to smooth that out a little bit. And that was pretty simple, thankfully enough. All I needed to do was set a smaller time window for capture. I needed to set a delay between each of my keywords that I used, an approximate time between each keyword as well, so 2 to 3 minutes, and hard set those cron jobs in Splunk so that it ran more smoothly. And once I figured out the sort of best time to capture data, I started to see more consistent data delivery through Splunk as well. And that's represented there in that graph. So now that we've got some data, what do we do with it? And there's some really simple things to do with this at this point. And we've got a feedback loop to, oops, never mind. I was just reading the Zoom chat window. Okay, so once we've got this data, we can start to focus on what we want to do with it, and what we can focus on from this point. And in these dot points here, I want to focus on what hashtags are coming up as the most popular, who are the noisiest users, what kind of tweets are liked the most, and who has the most mentioned names in a tweet as well, indicating noisy users. And once I had a baseline, I focused mostly on hashtags at this point because I wanted to use those as keywords. And in the keywords example here, I have, that's all good, Silvio. In the keywords here, I have quite a few things like China flu, coronavirus, COVID, all the variations of COVID-19. One of my favorites, which is the COVID idiots. Lockdown, pandemic, Rona, second wave, which has come up fairly recently. Stay home, and Trump virus, another personal favorite of mine. And once we have decided on the keywords, we go through the feedback loop that each time we've captured a new one, we collect, we analyze it, we verify the data is correct, we course correct, which is just adding a new keyword, and then we go through the same process again. But once I started capturing this data, I noticed something is a bit wrong with it. And that is that there's so many users, it's so noisy. There's bots, there's news articles being tweeted, and there's just a lot of unpopular tweets as well. So I needed to find a way to start, actually I have a little term here that a friend of mine used, which is cleaning the garbage. So I had some very simple logic checks in here. which are represented here in the Splunk query language, using eval statements and logic checks where we can specify a greater than or less than value of a field. So the logic check I used in these examples is where a tweet length is greater than a certain number of characters to eliminate short tweets where people only use a hashtag. And then I want to find tweets that actually have some sort of popularity to them so that we know that conversation's happening. And then I wanted to remove anything that had bit.ly links because I found that most of the time those were news articles. Once I had that data, I could go back through my verification steps again. I could actually look at the particular tweet itself by copying the URL inside the JSON data, visiting the tweet and verifying that all of my keywords and the usernames are met. And now I know that my data is correct. So once we're here, we can start thinking about the use cases we want to generate out of this so that we can actually make some value out of this data. And here I've created some really simple ones where we focus on graphing the data, tabling the data, and going into some more advanced things like sentiment analysis. So to start with, I wanted to focus on the most popular tweets per day. And here's my graph to visualize that. So I'll step through this search a little bit first. So first of all, we want to specify where we're looking for this data, which is in an index. We wanted to group together the data per day. We wanted to put everything into lowercase as well, specifically the username, because when I didn't have the user case in the username in lowercase, sorry, I was generating duplicate events. Then I looked at charting the data so that we could start visualizing this in a per day basis. And then we stream that data into this graph so that we could view those on a daily basis. And then we have this really nice view of who has the most popular tweets per day. And that isn't necessarily one tweet, it could be multiple tweets, but we look at the popularity of that person on a given day. The next one is the highest frequency tweeter per day. So instead of being popularity, we're looking at who's making the most noise. And it's a pretty simple thing where we're just looking for the amount of tweets from a particular user in a day, and we count those, and then we do the same thing, we chart them over a daily basis. And it gives us a really nice visualization of who is making the most noise about coronavirus at the moment. Then we go into the highest users of hashtags. So again, it's just about finding out who is making the most noise. And then the last one here was to find out who on average is using the most characters in the tweet. I still have a little bit of work to do on that one. I was finding it was going outside of the boundaries of Twitter, where it has 280 characters now. Sometimes it's getting 340 characters, which I found odd. But I averaged out most of those, so it should be a bit more accurate. And again, it's about the noise of these users. To save you the pain of going through each one individually, I focus more on these last bits, which is the table and the more advanced analytics out of this. So once we've verified how we get this data and we can visualize it, we can start to look at and correlate the time of the event, the user who created it, and the popularity of that particular tweet. Maybe a little bit hard to see in this example, but it's really hard to get these pictures into such a small screen. But we have here at the very top here the time of the event, the user who created that tweet, the tweet itself, and then how many like counts are on that particular tweet on that day. In this table, the most popular one is here, right about the bottom, where there's 94 likes for that particular tweet on that day. And then into the more advanced stuff, where we can actually start looking at the sentiment analysis and the engrams of these tweets and find out what the top terms or the most used word is in all of these tweets. And surprisingly enough, or unsurprisingly, COVID is the most used word out of all of the tweets that I've captured, which should be sitting around 400,000 events now. And then I guess unsurprisingly as well, coronavirus, pandemic, people, lockdown, case, social, get, Trump virus, and go. The bottom graph shows the sentiment analysis behind these tweets. It could be a little bit inaccurate. I probably need to train these data models a little bit better. we are showing more positivity than negativity. But then again, this could be related to people having a positive view on the current situation or current environment we're in, rather than a negative view. Whereas the negative views could be focused on Trump and all of the political arguments behind that at the moment. And the neutral views are based on, again, on the data model set that we have here. So now what we've got tweets, we've got keywords, we can identify users through the use cases that we have. And we'd want to go back through the feedback loop once we've identified noisy users. We can start focusing more on the people that are making those kind of noises, the people who are popular around coronavirus, and then we can generate more analytics behind those. And I think that's pretty interesting. So at this point, I think I've been talking about for 30 minutes. I actually have the option here to have a live demo if people have questions. So I open this back up to Sylvia and Kylie and the Slack channel. If you have a question of the data, I'll be glad to see if I can answer it for you.
Over to the Slack. Are there any questions for Ben that we have that he can do a live demo on? I can see a few people are talking. There was discussion about Splunk versus Elastic earlier.
I think we have a few questions. I think the stream is probably slightly delayed, so
it is delayed.
Oh yes,
for them to start asking questions for the live demo. But while we're waiting, there's some other questions that were asked during your talk. Sylvia, do you want to turn your video back on?
Oh yeah, of course. This is classic streaming side channel.
So did you want to ask Eleanor's question first, Sylvia?
Yeah, I've got a couple of questions of my own actually as well. So I'm not an OSINTer by any means, stretch of the imagination, but I do know that they're like, if you think of like Kali for pen testing, there are Linux distros for OSINTing. One, what do you think of those distros? Are they useful? Are they not useful? And two, are you thinking about like getting this tool that you've done? And I love the idea that you've done like tech for human stuff. I mean, I love that human stuff isn't just about the analysis of humans talking. It's about designing the tools that let the analysts do the work as well.
Yeah,
so I love that. But are you going to introduce this into an OSINT distro? And what do you think of OSINT distros?
Yeah, so my personal opinion on OSINT distros, they're quite limited, unfortunately, because a lot of them are based around US OSINTing. Yeah. Once we start looking at Australian data, it's actually a lot more difficult to find people, phone numbers, and various things like that. So I find they're a lot more useful for US searches rather than Australian searches. So this particular tool is probably why it's interesting, because we can actually focus on people who are in Australia and start focusing on that data they generate. In terms of releasing this tool for an operating system, it would be difficult because this is quite Splunk focused, but the Twin application is designed to work on Elastic and any Linux operating system. So most of those OSINT operating systems would actually run this quite well. But you'd have to think about how you want to baseline your data and continue capturing from a certain period of time. So I absolutely can release this to my GitHub profile. I do need to clean up the code for a bit first, but I will provide it and send out the links.
So I have seen some of those like the on GitHubs and stuff. They have like the all encompassing, like this is the full list of like the universe of OSINT like links that you can go for. Like, yeah, are there any Australian related ones that are actually useful for us? And you're still on
yeah, I'm just getting the Twin application. Yeah. It's okay. Yeah. So I have searched for useful Australian stuff, but again, a lot of it's very US focused, and the Australian stuff that we kind of need to capture on are just sort of government websites or any Google searching that we can focus on at the moment. There are things like username searches and email searches that are quite handy, because a lot of this data that we use to find for usernames and email addresses are US focused again, because they're usually things like Gmail, Facebook, Twitter, etc. It's all US focused, unfortunately.
Are there any websites that actually just literally like have a business, Australian business search, or like ASIC or something like that? Are there like any stuff that's out there that does that stuff?
I haven't actually found anything related to that yet, but that's a very good point. But I have used ASIC and various tools like that, which are just government websites to do OSINT work on. Yeah.
Okay. Well, seems to be, we're not that small a country. Surely there should be something out there. I don't know. So what's
so there are a few other questions, not just Silvio's questions here. There's a few other ones. So Louis asked, and I don't even know how to pronounce his question. Have you done some Levenshtein,
like string edit distance and stuff like that
on the tweets?
Hang on. Well, I'm trying to say that question actually. I'd probably not, but because I don't think I understand what he's asking.
I think he's just saying like fuzzy matching of tweets as opposed to like exact matching. Yeah.
Okay. No, I haven't. But I imagine with some of this sentiment analysis and the more advanced tools, we could probably focus on stuff like that. Yeah. But we're focusing on capturing keywords rather than looking at modifying or looking at what the tweets have in it in particular. But the tweets hold the most interesting information. And we can use that to go through the feedback loop again. So once we find something interesting, we can put that into the keyword search and start downloading that data.
And there was a question by Eleanor talking about like the approach that you're using now, the feedback loop of finding keywords and associated keywords. Is there a way to automate like the keyword association or something like that you can like automatically find new keywords and expand the search?
Absolutely. But do you want to automate that kind of thing?
Yeah.
It could become a nightmare. You'd have to have some pretty powerful searches and servers to run that kind of stuff, right? Like I said, with the GNU Parallels, I used up all 32 gig of memory on my server within an instant, trying to do several hundred searches at a time. So yeah, you could, and you'd have to time it very carefully as well. But you could automate things like that. So you could find top keywords per week and then just start focusing on those keywords. Splunk is very flexible in terms of application development like that.
Yeah, well, another question by Louis about what is the funniest like online tweet or something related to this topic that you found?
Oh, that's a great question. It does have Unicode search and compatibility. So I suppose we could find the Unicode for the laughing faces and find the tweets related to that. Why don't I try that quickly? Unicode for, what's the laughing face called? Laughing face. Let's see if we can have a look for that one.
I've barely progressed.
Here it is.
Colin.
So let's copy that and just dump this into here. We'll just do we won't even focus on, let's put it to this, which is the field extraction I have here. And we'll just look at the last 24 hours and see if we can actually generate, anything out of that.
Looks great.
My field extraction correctly. Here we go. So, oh, no, nothing's worked. Okay. Oh, add the wildcards in between that as well. That'll probably help me out a bit. There we are. And if we search for that, okay, great. That's good. So then we can ask the data to be a bit more clearer. So we can stats count by username and the translated field. Did I not spell something correctly?
I think translate.
Oh, yes.
The second translate.
The second one.
There we are. I'll just copy paste it. Makes my life a bit easier. There we are. Okay, great. So I guess, is there anything funny in there? I have seen some funny things.
Very tropical. I like that. Very tropical. And the first one.
There we are. But I cannot remember the tweet it was. And I should have saved the ID of the tweet because there is so much information in these tweets itself. And the API provides even more data out of this. So, if we look at this particular example here, where we have the laughing face in here, we can see the translated and the tweet event there. They're both in English, but we also get the same data to show us whether it was in English originally or another language. But then there's other things like the translate ID, the link, which I showed in the presentation as well, any photos related to this event, and replies to as well. So this is really quite rich data from Twitter.
Yeah, wow, that's great.
And following on from that, Ian actually said, were there any Silvio related tweets in there?
I'll have to add that as a keyword and get back to you on that one.
Okay.
I did see a tweet before that said that macaroni wasn't salad in the last page that you had. So for me, that's pretty funny. That's a good joke. So
I'll tell you what, why don't we ask the question of the data?
This
see if we can get Silvio at all. Nope. Lucky you, Silvio. Haven't talked about coronavirus at all.
Damn it.
Ian also asked one other question. He said, you mentioned you did it the hard way during your talk. Why do you think it's important to not do things the easy way?
Yeah, great question. If you do it the easy way, you're focusing more on just the data at this point. I wanted to focus on the whole package, I suppose, and I wanted to put this in Splunk again because I prefer using Splunk as a data streaming tool. It was hard because they provided me the answer the whole time. I just had to use Elasticsearch, and I only needed to create cron jobs to streamline this data process. But if I did that, I wouldn't have learned much about the module of Twint at all, and the sort of dependencies required to run this application. So I think I learned a lot more trying to do this a hard way than just sort of following the easy methods which they provide and put it straight into Elastic.
I've got a silly question. I don't know if this is valid, but like, I'm curious myself, like, are most OCenters like, are they focused on the engineering or the tech, or are they just focused on the analysis? I mean, are there many people that combine both engineering and the other side as well?
It's a bit of both, I suppose. I guess I don't see a lot of people going to the extent I do for capturing OSINT data. A lot of it's just focusing on where a picture was taken, where a video was taken, and those sorts of things. But when you start sort of getting into the more detailed and technical things, people are building tools exactly like this, which is the Twint application, to download more data and look at this on a bigger scale. Because once you capture this data, so if you use the application to look for a keyword at a particular time, you're not focusing on a baseline of this data. You're focusing on everything that's available at this point. So if I used Twint to look for you, Silvio, I could find every tweet you've ever tweeted on Twitter.
Oh, I've got some embarrassing ones out there that I want to delete.
I mean, we could even, if we've got time, I can fire up my
no, please don't. Is that the time? It's not time for our next speaker.
It could be interesting, Silvio. But it's data, right? We're not going to see any embarrassing photos or anything like that. We would just see the data behind it. So
yeah, it is very interesting to see. Like, I love combining the engineering with actually applied uses of the engineering as well. I mean, engineering isn't just about building towers without reason. It's about having actually applied things as well and having an effect on the real world.
Yeah, absolutely. Yeah,
great.
All right, any other questions? Do you guys have any more questions?
I think there are a few more on the Slack, but if you want to just jump onto the Slack and
no problem. I'll start answering them in there.
Yeah,
definitely a few questions about Elastic versus Splunk.
Yeah.
Oh no, that's what I was really trying to be careful of. I'm like, I don't want to make this a talk about Splunk versus Elastic.
That's right.
But Splunk is a tool that I used, and we'll just leave it there.
Look, thank you very much for talking. It's a great talk. Love to see engineering combined with the actual application of engineering as well. So thank you very much.
Yeah, thanks to you guys as well. It was a great opportunity to talk. And again, you can find me on Twitter, LinkedIn, Twitch, or GitHub.
And he does some great streams as well, by the way, of his mountain biking. I have watched some. He's very good. And he actually is very talkative, actually, while he's cycling up these like insane